Hey everyone, welcome to 5.9. We're going to do a bunch of examples here. So let's just start off with this one right here. We have the integral of x plus 2 over the square root of 4 minus x squared dx. So yes, the square root is right there. And so now we want to be able to go through this. And if I look back to my this stuff right here and I say, okay, does this look like anything that I have? Well, all these have 1s on top. So not quite. That's not going to be real good. So I say, well, what can I do? Well, I know I can kind of rewrite this as the integral of x over the square root of 4 minus x squared dx plus the integral of 2 over the square root of 4 minus x squared dx. Oops, the dx should be right here. Alright, that's not a negative, it's a positive, just a marker spot. Okay, so we can actually break this up. Break that numerator up into two different parts, right? So that makes it a little bit easier. So now I can look at this one and say, okay, I'm going to say u equals x, a equals 2, and now let's see if we can kind of do something with that, right? So let's see what we can do here. All right, so if we go ahead and we set u equal to x, then we can actually try this maybe a different way. We might not even have to use any of the stuff that's right here. We might be able to rewrite this. So if I write this as, let's say u equals x squared. Let's try that. So let's not even worry about the a. That means du is going to equal 2x dx. And I've got an x here and a dx, so if I just divide this by 2, divided by 2, I'm going to be pretty much set. So I have the integral of 4 minus u to the 1/2 du. Right? Now can I just go through and figure this all out? Well, sure, because I could say like v equals 4 minus u, and dv would equal negative u du. So if I just put that 1/2 and make a negative out in front, now we're pretty much all set, because now I can say, and I know this is kind of weird to say v, but now we have negative 1/2 integral of v to the 1/2 dv. Okay, now I just did like a double substitution. Does that mean there's a problem with it? No, could I also have made this a negative and maybe cleared some things up? Sure, but I'm just trying to show you, hey, we can do substitution again and again. I'm actually going to write this down here. So I've got the negative 1/2, and then it should be 2 over 3 v to the 3/2. And then we got plus c. Right? So then I know that these 2's will cancel out, so I got negative 1/3, and v is really just 4 minus u. So it's going to be 4 minus u, and u is x squared. 4 minus x squared to the 3/2 plus c. And that should be our solution. Okay, so that's the first part of what we have. And now why don't we do the second part, this one right here, because we had split it up, right? So we've got, that's going to be plus the 2 over the square root of 4 minus x squared. All right, and we have that integral. So that 2 can kind of even go out in front, right? And then we've got some things we can do with it. So why don't we just put that 2 out in front, make this into a 1, and we say, okay, which one has something minus the x squared? Oh, this one does. Inverse sine. Yes. So we can say that a equals 2 and u, let's just say u equals x. All right. So then we can say this whole thing is going to equal the arc sine. I'm going to put that 2 up in front. 2 arc sine, and let's just get this part right here. I've got it over here. Okay, and then it's going to be x over a, which in our case is 2, plus c. So I've got these two added together. All right, so I could have negative 1/3 4 minus x squared to the 3/2 plus 2 arc sine x over 2, and then all plus c. I only have to do that plus c one time. All right, so that kind of helps out with this problem. Now let's go on to the next one. Before we go on to the next problem, I actually made a mistake here. I know it's the first one ever. This should be a negative 1/2 because it was the square root. Oh, sorry. This one should be a negative 1/2 because it was in the denominator. The square root was in the denominator, so it should be a negative 1/2, which changes this to a positive 1/2, which changes this to a 2 over 1. So these actually cancel out. It should be a negative, and this 3/2 should be a 1/2. So that should be not 3/2, but 1/2 right here. So that should be 1 over 2, or the square root of that. And this 1/3 should actually cancel out. It should just be a negative, and that's all. So I'll rewrite that. Make sure you have the answer here in just a second. All right, there we go. So it is negative square root of 4 minus x squared plus 2 arcsine x over 2 plus c. All right, so first mistake I ever made. Now let's go back and let's look at another example here. The integral of dx over x squared minus 4x plus 7. Now they put the dx on top. Does that really, or I put the dx on top, doesn't matter. It's the same as saying 1 over and putting dx at the end. So it's just a different way of writing it. So what I want to do is, this doesn't look like anything we have going on over here, right? But what I want to try and do is, I want to try and get this to be like completing the square kind of a thing, all right? So if you remember that, you're going to take that b value of negative 4, divided by 2, and you get negative 2. All right, so that means I know I'm going to be able to write this as x minus 2 squared. All right, but now what do I have to do to complete the square? Well, I got to take negative 2 squared and get to positive 4. All right, so this number, this 7, should be a 4. So if I break up that 7 into 2 parts, a 4 and a 3, I could rewrite this as x squared minus 4x plus 4 plus 3. This right here is my square, and I can rewrite it as x minus 2 squared and then plus 3. So this is really the same as the integral of dx over x minus 2 squared plus 3. And now I say, do I have anything that looks like this? Well, this one looks a lot like that, right? I know that x, in this case, let's say u is going to equal to x minus 2, and a is going to equal to the square root of 3. Okay, so if I have all that, then I can just use this inverse tangent or arctangent. So I can say this is going to be the same as arctan, okay, of 1 over a, so it's 1 over the square root of 3. We'll change that up later and make sure we rationalize the denominator, of x over a, so it's going to be x minus 2 all over a, which is the square root of 3, and then plus c. Okay, we don't want to leave it like that, but we could maybe, actually, we can change some things up. But look at this. It's 1 over the square root of 3. Oh, wait, did I write that wrong? It should be 1 over the square root of 3 here, not here. Oh, man. Mr. Bartman, you're making so many mistakes. But Mr. Bartman, why do you make so many mistakes all the time? And I will refer you to the video of what you look like from my point of view. Okay, so that should be the 1 over the square root of 3 right there. So we could really say this is the square root of 3 over 3 arc tan of the square root of 3 x minus 2 over 3 plus c. We can put all that in parentheses, and then that would be our solution. Okay, so there you go. That is those questions. Those we have some completing the square that you have to do. Some other ones where you might just break some apart. You might use some of these right here. Sometimes you might not. There might be questions in there that might just say like, good luck. And they might look like this, but they're going to be disguised as something else. So don't automatically think it's just going to be arcsine, arccosine, arctangent, arcsecant, whatever. Because it may or it may not be. So just remember all of your rules. Okay? Good. There you go. And good luck.